As we move along here in our study of logs, one thing I have to stress again is that you have to know these log properties backwards and forwards. The product property, log A, argument u times v, one log splits up into two logs. However, you also have to recognize that log AU plus log AV, we can condense two logs as long as they have the same base and we have a plus between them into UV. And you have to know this backwards and forwards and exactly as it is to be able to justify any moves you make. We know in the quotient property, log base A of u divided by v, that's the argument, becomes log A of the numerator, u, minus log A of the denominator v. That's expanding the log. You also have to be able to recognize that if I give you log AU minus log AV, the bases have to be the same. We're going to get log base A of the first divided by the second. There's our argument. And lastly, log A u to the n. What happened with this n exponents is it became the coefficient. So what you also have to understand with the product property is that log AU and log AU becomes log AUN. I take that coefficient and I bump it up. Notice what's happening. When I go this way in red, I'm condensing. Two logs become one. Quotient property, two logs become one. I'm condensing. And here, this is often my first step when I'm condensing. The coefficient becomes the exponent. If we're asked to if we're asked to condense the log expression, when I see these directions to condense, and this is going to be a precursor to us solving log equations, when we are asked to condense the log expression, we're going to try to write the expression as simply as we can. In other words, we want to condense this down to one log if possible. And there's two things I always think of. Number one is I think of get rid of coefficients. That's the first thing I do. And second, and equally as important, is I work left to right, two at a time. And if you follow those two simple directions, you'll get every single condensing of log problem right, and eventually you'll get all of solving log equations correct as well. So first things first, I want to get rid of my coefficients. I'm using the power property. N log AU becomes log AU to the n. When I'm condensing, that's what I'm doing. And I'm recognizing playing the role of n in my first term is 1/2, and playing the role of n in my second term is 3. So what I'm going to do here is I'm going to take those coefficients and bump them up and make them exponents. First step, write it as log base 10 x to the 1/2. Understand that that means we're taking the square root plus log base 10 of x plus 1 to the third power. Now that we've got them all alone, peke yake, as we say in Swahili, meaning this is one log and this is one log. Now we can use our rule because we have a plus sign here. We're going to use log AU plus log AV becomes log AUV. That is our product rule for condensing. Playing the role of A is 10. Do we really need to write that? No, it's the common log. So this will become log base 10 of x to the 1/2 times x plus 1 to the third power. And that u times v is the argument of my log base 10 expression. Of course, if you wanted to, this is a fine answer. This is correct. If you wanted to, you could write this as log base 10, the square root of x times x plus 1 to the third. Why can I do that? Because this is the same as that. Which one do I prefer? Who cares what I prefer? Either one is fine. If we're asked to simplify this log expression, I'm sorry, not simplify, but rather condense, we want to write two logs as one log. Of course, when you see natural log, you have to be understanding that the base here is e. You think this, but you write that. Now, remember, the rules of engagement are going to be that your coefficients are going to become exponents. That's your first step, and we're going to work left to right, two at a time. Now, there's only two terms here, so that doesn't mean much to us, but I'm going to show you one later that it's going to be critically important for us. If you follow those two rules, you'll be great at this, and then subsequently you'll be great at solving log equations from chapter 3.4. So take care of the exponent first. I'm recognizing this is like n log a u, and I'm going to make that log a u n. I'm going to use my power property here. So I write this as, natural log of x plus 2 squared minus natural log x. Now recognize that we have log base a of u minus log base a of v. This is the quotient rule, so that's log a u divided by v. First argument divided by second argument. So once we get here, write this now as natural log, that's base e, of the first divided by the second. And this big quotient becomes your argument of the log with base e. If we're asked to condense this expression, I would probably say, well, let's just follow PEMDAS and work inside of this big parentheses first. Notice this is the equivalent of log a u plus log a v, which by our product property will become log a u v. In other words, I could write this as the 1/3 comes down for the ride, and this will be log 2x times x minus 4. Now, notice x times x minus 4 is our argument of log with base 2. And then what I'll do is I'll pump this up here. The coefficient becomes the exponent by the power property to give us log base 2 of x times x minus 4 to the 1/3. Now, that is a fine answer. You know from your study of algebra that if you have a, b to the m, that you get a to the m, b to the m. Now, this is x to the first and x minus 4 to the first. Using this rule, my 1/3 will go to each of them. So that would be written as x to the 1/3 times x minus 4 to the 1/3. But we know what 1/3 power means. If you have a to the m over n, that's the nth root of a to the m. In other words, power over root. So to the 1/3 power is really the cubic root. So this is a fine answer. This gets you 100% wonderful. If you wanted to change it around, it would be log base 2 of the cube root of x times x minus 4. And there is your argument. Either way is fine. They mean the same thing. Myself, I would probably use my PEMDAS and say, well, order of operations dictates I must do what's inside parentheses first. What if you didn't? What if you said, nah, you know what? I want to distribute this 1/3. Well, that would make this 1/3 log base 2x plus 1/3 log base 2 x minus 4. You know me, I want to take care of exponents first. So I, by my power rule, would do this and make this log base 2 x to the 1/3 power plus log base 2 x minus 4 to the 1/3 power. And now I could use my product rule and say, because we have the same base here, we could write it as one single log base 2 of x to the 1/3 times x minus 4 to the 1/3, which we saw is the equivalent of, here's the advantage of using the whiteboard, this to the 1/3, which we saw is the equivalent of, wait for it, this. So either way, however you want to write it, at the end, you have 3 different options for answers there.